All right, so we're going to write some more equations of lines on this second video. This one says find an equation of the line, and then to write our equation in function notation. And so we've already had a little bit of experience with function notation, so hopefully you recall that. Now, what we're going to do here first is notice that this says use the point slope form to write the equation of the line, but we're given 2 points. So this time we're not given the slope, and that means we have to actually find the slope of the line. So first, let's find slope. This is going to be -8 plus 3 because it's minus a -3. And then it will be 4 minus 8. So that's -5 over, excuse me, -4 for a slope of 5/4. Remember, improper fractions are best here, so we're not changing this to a mixed number. Now, when we write our equation with point slope, we only need one of these points. So you just choose, which point do you want to use? It does not matter. We are going to use the slope of 5/4. And then I think I'll just use the first one. It doesn't matter which one. Okay. And so into our formula, we'll put -3 for the y. So that's going to be a +3, right? Minus -3. Then 5/4 for the slope. And x minus 8. We will distribute the 5/4, so 5/4 x minus. Now there's different ways you can look at this. 5 times -8 is -40. -40 divided by 4 would be -10. And then of course we're going to subtract the 3. And then let's write this with f of x, right? F of x, because we're writing it in function notation. I'm kind of skipping ahead to that so I don't have to write it one more time. Whoops, that's a 4. It would be good not to change the slope at this point. Right? And there we have it. This is the equation. Now we have it written in function notation. Y equals 5/4 x minus 13 is the same as the f of x. They just are a different notation. Okay, so on this one, we're finding the equation of a line on a graph. Now, what we could do is just count our slope. Now, you have to count carefully here sometimes because it's kind of squished together. And on this, we're going to have a rise of just 1. And this is a negative slope because it's decreasing. So my slope is a -1 over, right, down 1 over 1, 2, 3, 4, 5, 6, 7. So my slope is -1/7. It's just easier in this case to go ahead and count the slope. And then from there, I need a point, right? I need a point on here. So I'm going to use this one at -4, 0, right? So point slope and a slope of -1/7. And my x-intercept, I need a negative in there, -4, 0. Okay, I like zeros because that makes it a little bit easier actually. So I will have a y minus 0 because my y coordinate is at 0. -1/7 times x minus -4 would be +4. I can drop the 0. And now I have -1/7 x minus 4/7. Now this one was write the equation in standard form. So we have to add 1/7 x to both sides. All right. Plus y equals -4/7. And then we have to clear the fraction. The x is positive, so we're good with that. We clear the fraction by multiplying through by 7. So in standard form, this will simply be x plus 7y equals -4. And then it's written in the form that's supposed to be. That's one thing you'll have to pay attention to as you're working through these on MyLab, is really pay attention to the form you have to put it in. So you're not really finished sometimes once you've written the equation, because you have to pay attention to that. It will either be standard form, slope-intercept form, or function notation. That's the 3 choices that you'll have. All right. These are some that are kind of thinking kind of questions, okay? It says write an equation of each line. And so the first one says we want our line to be horizontal and it needs to go through at -3, 1, okay? So if I look at this on a graph, let's just put a graph right here. Just a simple little graph. I don't have very straight lines, and I still don't. Okay. All right, so if we're at -3, 1, I'm just going to estimate, and I want this to be horizontal, then that means that it's going to go through this point, which is at 1. If only I could draw a straight line, right? And that's at y equals 1. So that's the equation of my line, y equals 1. Remember, a horizontal line will be y equals a number. And then on the next one, if I put it on the graph, let's see, we're over here at 2, 5. So I drew that too long. I'll just draw it like this. Okay. So I'm just going to once again kind of estimate. Here's my 2, 5, and it's undefined. Well, undefined means vertical, right? So it's a vertical line. So it's at x equals, notice, this is going to be at x equals 2, right? Because that's where it goes through the x-axis. So x equals 2. It has to be the x-coordinate of the ordered pair, just like on the first one it was the y-coordinate of the ordered pair. Okay, so on the next one it says we're going to be parallel to y equals 9. Well, y equals 9 is a horizontal line, right? Y equals 9. And that means that we need another horizontal line, which means it has to go through at -5 because that's the y coordinate. So it will be at y equals -5. There's not really work involved here. You just have to kind of think through this. Once again, okay, so y equals 9 is horizontal. We want this one to be perpendicular to y equals 9, right? So it has to meet that in a 90-degree angle, which makes it a vertical line. If it's vertical, it's x equals, in this case, 5, because that's my x coordinate. And so that's really all the work involved in these. Okay. Next, find an equation of each line, write the equation using function notation. So when we finish, we'll have it in function notation. Notice it's starting in function notation, so that's handy. It has to go through the point 1, 5 and be parallel to the given line, okay? So this line has a slope at 3. So if a line's parallel to that, parallel would have a slope of 3. Okay, and we need to know that because to write this equation, we simply have to know the slope and the point. Okay, so we're going to write the equation of the line using point slope. We know our slope is 3 now. and the point that we have to go through is at 1, 5. All right, so let's substitute into the formula. It will be y minus 5 because 5 is my y coordinate. 3 times x minus 1. So that's 3x minus 3. We're going to add 5 to both sides. And then we get y equals 3x plus 2. And write it in function notation. All we do is replace the y with f of x. And there we have it. Okay, and that's it. The next one has to be perpendicular. So I'm subtracting a 2x because I have to find the slope of this line. I'm getting a little low on time and I don't want to make a third video because we're on our last example. All right, so my slope is 2/3. The line I'm writing has to be perpendicular to this line. So since this slope is 2/3, my perpendicular slope is going to be the opposite reciprocal, which is at -3/2. We're writing this one in slope-intercept form. Okay, so excuse me on that. We're going to write out our formula and then substitute in. So remember, I'm using a slope of -3/2. It will be y minus 8 equals -3/2 times x minus -4 would be +4. We're going to distribute -3/2. So -3/2 x minus, that's like -12/2, so -6. Add 8 to both sides. So the equation of this line will be -3/2 x plus 2. And so we've written that and we're finished. It is in slope-intercept form. Okay. So we've gone through lots of different things on this lesson. This is kind of brings it all together and tells you all these different things that we did. This is from your textbook or your ebook. I just snipped it and I have it on this slide so that you can see standard form, slope-intercept, point-slope, what's the equation of a horizontal or a vertical line, and then information about parallel and perpendicular. So this might be a handy chart to keep somewhere where you can look at it when you're working on these types of problems on section 3.5. All right, and that's it.